The demographic disparity between Israel and its neighbors, 9 million inhabitants compared to approximately 120 million combined in Iran, Syria, Lebanon, and the Palestinian territories, contextualizes the constant military tension in the region. With a history of 10 wars in less than 70 years, Israel has learned to operate in a state of permanent readiness since the first day of its independence in 1948. This scenario of recurring conflict, which statistically manifests itself every 9 weeks, justifies the investment of a quarter of the national budget in defense. To survive this pressure, the country developed a layered defense architecture, beginning with the Iron Dome, designed to intercept short-range rockets using physical interceptor missiles. However, the need for a more agile and economically sustainable solution led to the creation of the Iron Beam, a laser defense system. But before we begin, don't forget to like and subscribe to our channel. The use of lasers in air defense offers fundamental strategic advantages that differentiate it from conventional systems. While an interceptor missile needs time to accelerate and maneuver to its target, the laser beam travels at the speed of light. This allows it to hit high-speed and extremely maneuverable targets at short distances, where reaction time is minimal. One of the biggest challenges of the Iron Dome is the cost. Each Tamir interceptor missile costs tens of thousands of dollars. In contrast, the Iron Bolt consumes only electrical energy, making the cost per launch practically negligible, estimated at a few dollars. Missile systems rely on supply chains and physical resupply. The laser, provided there is a power source, possesses infinite ammunition, which is crucial during saturation attacks, where the enemy attempts to overwhelm defenses by launching hundreds of projectiles simultaneously. The transition to laser technology represents the search for an impenetrable wall capable of dealing with the predictability of ballistic trajectories while simultaneously neutralizing agile threats such as drones and mortars, ensuring that the country is not economically exhausted during prolonged conflicts. But it's completely different when an enemy missile is just a few kilometers away, and moreover, it's necessary to calculate its trajectory while it's still maneuvering. Destroying it becomes an almost impossible task. With laser weapons, it's not necessary to calculate the missile's trajectory. Simply point at the target, fire, and destroy it. The second advantage is the relatively low cost of eliminating the target. Qassam rocket, with which Hamas bombards Israel, costs approximately $600, while the Tamir missile of the Iron Dome system costs about $80,000. Considering that 2 Tamir missiles are fired to intercept a single enemy rocket, spending $160,000 to destroy a $600 projectile is something no economy could sustain for long. With a laser weapon, each shot costs about $350. In other words, practically the price of a cup of coffee. The third advantage is the reload time. One launcher holds 20 Tamir missiles. After use, they require several hours to recharge. During this period, the area protected by the battery is practically defenseless. The laser, on the other hand, can fire continuously without needing to be recharged. In other words, Israel, more than any other country, needs a laser-based air defense system. Therefore, Israeli experts began working on this topic back in the 1970s, with the participation of companies such as Israel Aerospace Industries and Rafael Advanced. Defense Systems studied the main aspects of these weapons and built prototypes. In 1976, the laboratory tested the first gas dynamics laser with a power of about 10 kilowatts. Later, the development of chemical systems began. At the end of these studies, the experts concluded that a combat laser with anti-missile defense capabilities could only be created in the distant future and under favorable conditions. And they were right. Israel's second attempt to develop laser weapons occurred 20 years later, in the mid-1990s. In July 1996, the United States and Israel agreed to develop a joint project for a mobile high-energy laser system. The project received the official designation MTHEL, Mobile Tactical High Energy Laser. Its objective was to create a defense system against short-range missiles. The complex was based on a chemical laser that used deuterium fluoride. This system was designed to achieve a power output of up to 2 megawatts, sufficient to destroy artillery shells and unguided rockets in flight. At the same time, the laser itself required a range of additional equipment to ensure its operation and to fulfill its assigned missions. The project's development faced significant difficulties. The deadlines for the different stages were constantly postponed. And although during the 2000-2001 tests, the system successfully destroyed 28 unguided rockets and 5 artillery shells on predictable trajectories, the military was not satisfied due to its high complexity and high cost. Therefore, in 2005, Israel abandoned the project and began developing the missile defense system. Kippot Barzel, better known as the Iron Dome, destroys targets using interceptor missiles. Now, after another 20 years, a third attempt has been made to create a laser weapon. In 2014, the company Rafael presented a new project called Karen Barzel, or Iron Ray. It was a mobile system capable of hitting various types of aerial targets with a laser beam. These targets included rockets, projectiles, and drones. The system included 2 trucks with containers equipped with high-power solid-state lasers. For target detection, there is a dedicated radar station. The command post coordinates the interaction between the system's components. It must automatically identify threats, point 1 or 2 lasers depending on the type of target, and destroy it by transferring thermal energy in a few seconds. It is possible to fire 2 lasers simultaneously at a single target, and the maximum range is approximately 7 kilometers. The development of the Iron Ray was accelerated due to the increased threat of precision missiles from Hezbollah on the border with Lebanon in December 2018. In addition to constant attacks from Hamas, the Weapons and Technology Development Department, led by Danny Gold, coordinates the entire project. The program's cost reaches billions of dollars. Although it is classified, defense industry sources claim that the developers have overcome significant obstacles. They have managed to create a laser capable of focusing quickly and accurately on the target. Other challenges include the enormous energy consumption, mobility issues, and difficulties in adverse weather conditions. Nevertheless, the Israeli Ministry of Defense is determined to put the system into operation. The capabilities of the Iron Dome are already showing limitations. Since entering service in 2011, the system has intercepted approximately 2,000 missiles, and in the last conflict on the Gaza border, it managed to intercept 75% of the attacks. The Army predicts that, in the event of an escalation, up to 1,500 missiles per day could be launched against Israel. The Iron Dome would not be able to handle this volume, and missile stockpiles would be quickly depleted. On January 8, 2020, Israel announced significant advances in laser weapons, already tested in the Gaza Strip, with an interception rate close to 100%. Operational guidelines have already been established and foresee the system operating at distances ranging from hundreds of meters to tens of kilometers, guaranteeing extremely economical interception, costing only a few dollars compared to the thousands required for each Iron Dome launch. Although the initial operational forecast was for 2020, the project has continued without recent public updates, suggesting a high level of strategic secrecy. This technology will represent the 5th pillar of Israel's missile defense structure, adding to 2 other laser systems that the country claims to be developing. The first of these will be mounted on ground vehicles to protect military units within a radius of up to 4 kilometers against threats such as drones and mortars, with field tests scheduled for 2025. Simultaneously, a second variant will be installed on large aircraft such as the Hercules, allowing for the neutralization of missiles above the cloud layer. Israel has already presented records of similar aerial tests and assures that the laser has the capacity to operate in diverse weather conditions, overcoming obstacles such as fog. With these advances, the nation reaffirms its leading position in the development of modern weaponry, demonstrating how a country of small territorial proportions can solve technological challenges that still confront major global powers. Tell us in the comments what you think of this new laser defense system. Until next time.